Violent suggestion are many a reliable suggestion and recommendation in order for us to have a very comprehensive discussion for to at this juncture. Right? You get the point, ganon. Okay, guys. Nakakaloka, no? Char. Okay, naluluka na si Junjun. Okay. Okay, like that. Okay. Oh my gosh, I love it! Right? Oh. Oh, naku di ba? Okay. Now let's go back. Okay. Heat capacity is the amount of, okay, heat energy, okay, required. Just analyze the action verb like that. The amount of energy required, okay, to raise, okay, the temperature of 1 gram of substance as our basis, 1 gram of substance to 1 degree Celsius. Again, heat capacity is the amount of heat energy required to raise the temperature of 1 gram of substance to 1 degree Celsius. Sometimes also it could be of 1 kilogram of substance to 1 Kelvin, things like that. Okay? Because that's only basis of your calculation at standards temperature and pressure, things like that. Now, some books also in chemistry or physics, they don't put amount of heat. They would just say the amount of energy required to raise the temperature because we are giving already the title heat capacity. It's understood to be the heat. Okay? You get the point. Your important clue here is to put energy. So this is your keyword. Energy, temperature, 1 gram, and Celsius. These are your keywords. And now you rearrange that by using your own grammar and sentence so that you can have your own definition. Sometimes you will say, the amount of energy that is needed to increase, okay, to increase the temperature of 1 gram of substance to 1 degree Celsius. So it's up to you how you will manage that. You will change the word required, you will change the word raise, okay, you will change the word also amount sometimes. You get the point? Okay, things like that. Okay, well, you will see also the energy necessary to raise, because once it is an energy, it is obviously an amount. Okay, direct to the point. But since we are trying to be specific here, that's why we'll say amount of energy. But actually, when you say heat energy, that's already an amount. Okay? That's why I told you it depends on you how you construct your sentence if you have the definition. Things like that. Okay? Now, so that in your trainings, in your discussions, you don't have to look and read all the time the slides. Things like that. You will have to show that in the projector and you can walk. You can face the audience, you can look at the projector, so that your training will be challenging. Things like that. Because to maintain the impression, things like that, that you are really a professional. Because that's not professional if you're teaching the students looking only in the books, okay? And only looking at the laptop and even without doing the eye contact. It's okay, you will be forgiven, of course, because we are just human being, okay? But once you read the text from the laptop, you need also to eye contact the audience. It's not reading and you do not face the, what's this all about? There's no interactive way of, learning, things like that, between the speaker, the teacher, and the students or the participants of the training or whatever. You get the point, things like that. Okay, this is heat capacity. Okay, you understand now? Okay, things like that. Now, there's a gray area for this. Some books are stating that if you put gram here, you will add specific here. Specific heat capacity, in which I believe this is the most appropriate terminology. Why? I will explain. Okay, get the point. Things like that. Because, there's there's a mismatch on the unit and the terminology. But I don't think so. Vloggers, science vloggers also don't match when they talk like that. It looks like okay because they refer also the books, obsolete books, ancient books in which it has not been corrected, strictly and meticulously or explicitly, meaning not really corrected in a detailed manner. Okay, everything will be considered the spelling, the phrase, the grammar, the vocab, the punctuations, the numerical figure, meaning the entire rubric of your content in your books. That's the rubric, the general assessment or evaluation. Okay, that's the meaning of rubric in English language. Okay, get the point. Things like that. Now, so specific heat capacity, this is a calorie, gram, degrees Celsius. Okay, it's also joules per gram degrees Celsius. Now, your definition in most of the books doesn't qualify because you mentioned the gram. You get the point. Oh, maybe it's just me, or maybe it's just understood, that's why nobody corrected. But it's not really specific. So it's better to say the amount of heat energy required to raise 1 gram of a substance. No need. Oh, yes. Okay, the amount of heat energy required to raise the temperature to 1 degree Celsius. There's no substance. For example, I have 3 pieces of aluminum here. Aluminum, molecular weight, atomic weight of aluminum, how much? 26.98 grams per atom. Right, I have here. Okay, then I have only 2 pieces of aluminum here. Okay, so are they having same specific heat capacity or heat capacity? So this is where the theory applies. You can understand by looking the definition. So if you will say heat capacity, oh, and then there's gram. This is supposedly the specific heat capacity. Things like that. Okay, because these two examples or comparative, if I have 10 pieces of aluminum like that and I have 2 pieces of aluminum, they have the same, okay, they have the same heat capacity, but they don't have the same specific heat capacity. You get the point? So this is where the clear or the clarity that our definition must be revised and modified, because to be strict, it doesn't qualify anymore by general understanding, by understood, because the word loves too much of understood. This means directly like this means directly like this. So no more elaborative way of discussion. Okay, for example, if I say salt, like that, you mean of the salt is sodium chloride only, but there's a lot of salt, potassium chloride, potassium carbonate, like that. Okay, so in the context of science, that will not hold true for all the salts. That is just the salt you see in your kitchen, but there's a lot of salts other than that. Since you use that in your food menu to improve the taste, that's why we mean sodium chloride. Okay, let's accept that fact. But here, this is really heat capacity specifically. This is more on the deep theoretical aspects. You get the point? Now, the amount of heat energy required to raise the temperature of 1 gram of substance, this is specific heat capacity. Okay. So, I will say, for this, okay, the two, group A and group B sets of aluminum pieces, or whatever you call that one in description, so they don't have the same specific heat capacity, but they have the same heat capacity. Okay, because you put them in the same room at the same temperature and at the same pressure at standard condition, then the masses are not the same. Okay, you got that point. Though the molecular weight is the same, it doesn't mean also that your molecular weight is the same. Okay, your specific heat capacity will not change. Okay, so this is the relevance why we need to be strict in the word-for-word definition in science. Okay, because it matters a lot. Even a single article, pronoun, adjective, conjunction, things like that. Okay, phrasal verbs, action verb, main verb, linking verb, like that, okay? Modal verbs, things like that. And your clauses, coordinate clauses, okay? Your conjunction boosters, grammar, and everything. Okay, get the point? Now, this is in this topic, guys, that I think I realized this in third year college. Oh, I come to, I stop for always, oh my gosh, things like that. I discovered it by myself. Okay, got the point, things. Okay, so through constant research and reading. Okay, while walking. So while walking, learning like that, because I need to remember while walking also. Okay, while walking, while sitting in the jeep, my mind are always focusing on the study. You, grabe siya talaga, guys. You get the point, things like that, to the highest level. Okay? Things like that. Now, okay. Now, if you see specific, take note with this adjective, specific. In science, this would mean your unit of measurement involves mass. Okay. It should be in the denominator. This is the clue before further solving the problem solving, because not all the time we are very quick in the conversion. Sometimes we miss that also. Okay? Denominator. Okay. What do you mean by molar? So molar meaning the number of moles is in the denominator. It is said grams per mole. Oh, that is molar mass. Okay, things like that. Specific heat. Okay, calorie per gram. Degrees Celsius because the gram is in the denominator. Okay. Okay. Specific enthalpy. Okay, how can you say that? Calorie per kilogram. Joules per kilogram. The unit of heat and the denominator will always be the grams. Okay, because when we say of enthalpy, that's the same of heat content. You get the point. It's in physical chemistry, right? Okay, things like that. Okay, now if I will say the reciprocal of the concentration is A, like a B, C, like that. So a simple like that question in the board examination, for example, the reciprocal of specific volume. A, viscosity, B, surface tension, D, acceleration, ganon. There's a lot of choices. Okay, the reciprocal of your specific volume. So you need to inverse your volume, right? And then the problem is you don't know really what specific volume, as I told you. Because what you understand by volume is only the liter, milliliter, cubic feet. There's no denominator. Okay? Now, if you put specific and molar describing your volume, you have to put unit in the denominator. You got the point? So that's the time you will put liter per kilogram. Okay, cubic meter per gram. Okay, what else? Gallon per gram. Okay, what else? There's so many, right? Okay, cubic centimeter or cc per kilogram. Take note, the units in the denominator are kilogram, gram, like that. And the upper portion will be all about volume. That's why specific volume. Now, if the question will say the reciprocal of specific volume and you don't know the story about specific, you will just guess in your choices, right? So this is the power of theory understanding. Principle and concepts understanding. You get the point? Now, this will hold true for everything. Specific concentration, specific enthalpy, specific entropy, specific viscosity, specific like that. Okay? Including this one, specific heat capacity. All terminologies in science that involve specific, the denominator is always mass. Copy? Okay. I'm very strict, right? Okay. Gusto mo magkuhan guys, because I did not exactly get this when I was in third year. Second year or third year. And there's too much to know. And later I know that only in my review, things like that, and also working. While working, I still read a lot in science. Sometimes there are so many topics that I still don't know. Okay, things like that. You get the point? It's not a guarantee that you graduate to a particular profession, you knows everything about that particular curriculum. There's still a lot that our teachers and professors did not cover during their lesson plan. Okay, remember they are just paid to teach you. They are not paid to maximize your learning. You get the point? And they are not monitoring the teachers. Did somebody monitor the teachers and go to the classroom to watch what is their performance coming from the management of the university? Nothing, right? Nobody observed the way how they discuss. You get the point? So, how can we determine the effectiveness of their teaching even without somebody monitoring them? They can do what they want. Okay, things like that. So, meaning sometimes at minimum level only, average level only, but they don't hit the maximum level of giving various and vast topics to the students so that they will learn a lot that they can use in the future. You get the point? Things like that. Okay, because when you share your learning and knowledge, it is not something regarding with money. Okay, it's fulfillment without money. Okay, you get the point, Matt? You get the point? Just like me, I'm vlogging, sharing this educational information. Even though nobody watches at me, even though I don't have revenues, it doesn't matter as long as I inspire the young students to learn about science. Because it's a fulfillment. Fulfillment is regardless of everything. Okay? That's true happiness lies. You get the point? Ganon. So it's not equate with popularity. It's not equate for your high rank positions in your company. It's not basing on how influential you are as a politician. It doesn't matter how famous you are in your barangay. Things like that. It doesn't mean that you have a lot of 3 stories building. You have a very beautiful and luxurious sports car that you have. You have huge money in the bank. It's not regardless to that. When you talk about education, learning, and mentoring our younger generations. Okay, because they are our future, right? If we die someday, we will be just passing in this contemporary world. So our legacy that we share to them would be enough, and we will be smiling at heaven watching our children that they learned a lot and making the world go round. Scientific research improve the economy like that, progressive living with their loved ones. They're very happy with delicious food because they have very good job, a lot of scientists like that. So industrialized country because of scientific discoveries, modern and latest discoveries by means of high technology or state-of-the-art technology because of their innovation, invention. Okay, things like that. Very highly scientific, right? Okay, you get the point? Ganon. Okay, so muna siya. So the reciprocal of specific volume, we have, for example, so we have specific volume, so cubic meter per gram. So your answer will be density. Okay, blank is the reciprocal of specific volume. Your answer will be density. Okay, things like that. Okay, then I have also here, for example, liter per mole. Okay, the reciprocal of your molar volume, what is that? Quantity A, B, C, D. Your answer will be concentration. See, as quick as the question you can answer directly if you have the concept in your mind. You get the point? So like that. And the units will tell everything. Sometimes if you forgot, if you have the units, then you can remember the formulas. Okay? Things like that. That's why it's not advisable to memorize plainly. Okay, without understanding. You get the point? Things like that. Okay, now, we agreed already that this is going to be technically specific heat capacity, not the heat capacity, though sometimes it's correct by other books. Okay, the conventional or traditional or obsolete books. Okay, let's just say it that way. But to be specific, see, to be specific heat capacity really having this definition. The amount of heat energy required to raise the temperature of 1 gram of substance to 1 degree Celsius. 1 gram really is a representative mass only. It's not also word forward. For example, if you have 200 grams and you need to heat that, and it will achieve a certain temperature, that will be your specific heat capacity. Doesn't mean only 1 gram always all the time. This is only the basis. Okay, but the point, the standard basis of all. Ganon. Okay. Now, you have now the specific heat capacity. Okay. Now we go to the molar heat capacity. Okay. Like that. Molar heat capacity. So, revise your definition in the pattern of this. You will say, the amount of heat energy required to raise the temperature of 1 mole of substance to 100 degrees Celsius. Imagine, you only change the gram into mole and your terminology is already molar heat capacity with the adjective molar. Okay, this is the power of understanding, okay? And then number three, heat capacity. So heat capacity, you don't have to add molar and gram in your definition. This is what I told you now. So heat capacity. So heat capacity meaning the amount of heat energy required to raise the temperature to 1 degree Celsius by changing the phase. What do you mean by changing the phase? For example, solid to liquid, liquid to gas, gas to liquid, gas, solid to gas, like blah, 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 so and so. You get the point? So that is heat capacity. The addition only of changing phase, but the rest are the same. But you remove the gram because the unit of heat capacity is joules per degree Celsius, calorie per degree Celsius, like that. Or amount of heat energy or heat unit of measurement over different temperatures, whether Fahrenheit, Rankine, like that. That all are heat capacity as long as temperature is the denominator. But you remove the gram. Okay, so that is heat capacity, and you will add only the phase changes. So again, heat capacity, the amount of heat energy required to raise, okay, the temperature of a substance to 1 degree Celsius during phase change. Now, if you did not change the phase from solid to liquid, liquid to liquid, remains the same, and therefore that does not require heat capacity. You get the point? Because there's changes, phase changes. You get the point, things like that. Okay, now we go to the standards in which this will be my headache before, because I memorized all the specific heat capacity of water heat capacities of water, things like that. And I don't know that if I have that only one, I can convert to another one. So my purpose of that thing is that I can only remember without solving because I don't have time that much. Okay? But it's okay to have memorized only one. The rest you will do a lot of conversion. But for me, I'm comfortable with so many values because by the time it will be used there in the formula, I can use without any conversion na. You get the point? Especially if it's not open book, especially there's no mobile phone, there's no Google search engine in your examination. So how can you do that? You get the point? So what we do in our daily life is not an examination, it's not an assessment. That's why we need to use the cell phone all the time, the computer all the time. So if that is the case, you are facing an examination, you will be dependent too much because you do in the daily basis, you keep on doing the Google search. Okay, I'm not telling you to do the Google search, but do not do it excessively if you know already the concepts or if you can remember the concepts. Okay, especially basic concepts. Okay, so Google search engine is for complexity like that, in which you are confused and you need to confirm. Is this correct really? Things like that. You need to confirm, and somewhere along the way of confirmation, it will add another knowledge while reading like that. That is okay. But what I'm trying to emphasize, trust first your instinct knowledge or your inborn knowledge without any references when somebody asks you like that. You get the point? Without anything in your hand, then somebody will ask you, what is the formula of viscosity? Like that, and then you will be shocked, oh my gosh, what's this all about? Somebody asked me viscosity in the Lulu market. Okay, oh my gosh, how can I say this? And then, can you give me a blank sheet of paper? Because I want to derive before answering you. Because it will take a longer time for me to say that, because to answer you, because it needs derivation. And I couldn't remember that because it was a long time ago, last 30 years ago, since the time I graduated in my basic chemical engineering. Ganon. So many justification. And then the one will ask, okay, never mind. I'm just joking, by the way. Okay, thank you. Like that. Things like that. You got the point? It looks like strange, right? But you know, our mind is looking that very imaginative. Ganun kasi ako guys, my mind is very imaginative. You get the point? There are so many ideas in my mind. Sometimes it can go out. Sometimes it will stick. Sometimes it will not be used. Things like that. Especially, I'm working in OSH. Okay, so a lot of my knowledge about science and math has been stored in the hippocampus part of my brain cells, and other will not be shared because nobody will ask. And that also part of my job because if I do the trainings regarding not here in the past in state of Qatar in Abu Dhabi when I did the training, okay, it's not also training about science. It's a training about OSH, occupational safety, and that. So if you will not really expound your knowledge, then you will be losing your engineering knowledge somewhere along the way after 20 years, after 15 years, after 30 years. Okay, so nobody wants to be stagnant in terms of knowledge because knowledge is to empower our lives, right? Empower. Okay, so to do that is we need to have brain empowerment. Okay, get the point? Okay, things like that. Okay, because our brain is the central processing unit of all. Okay, like a CPU in your computer, in which all data will be processed there. And then if you try to put that also in an industries or companies, that is the central control room of a certain company or factory. So that is your CNS, central nervous system, in which the main contribution is your brain. Okay, and also your peripheral system also. The capillary veins that attached from the central nervous system going to the different vital organs. Ganon. Okay, diba? Okay. So, ana siya guys, no? So, we need to memorize the most important and basic and easy to remember. Start with 1. What are the standards, guys, only that we need to consider 1 lang dyan, no? Because it's very easy to remember if 1 or 0. Things like, okay, standard temperature like this, no? At STP. Okay, for ideal gas, it's 0 degrees Celsius. So 0 is easy to remember. Okay. Okay. Now, in density, what's really the standard of density of water? So 1, it's very easy. Right? Start with 1 and 0. That's very easy. Okay. Oh, so our topic for today is heat capacity and specific heat capacity. So I will start with 1 calorie per gram degree Celsius also. You get the point? So this is your unit of your specific heat capacity. Okay? Not the heat capacity because there's gram in the denominator. Okay? Things like that. Now, you may ask me, sir, in your Q is equals to mCp dt. What's that all about? That is specific heat. Because specific heat and specific heat capacity is just equal. But you may say specific heat and heat capacity will not be equal. Again, when you say specific heat capacity and specific heat is equal. But when you say specific heat, okay, and heat capacity is not equal. You get the point? Because the unit of specific always involves gram in the denominator. You get the point? Things like that. Okay. Now this is your specific heat or specific heat capacity. Okay. Now, if I will remove the gram, it will become now the heat capacity. Now, if I will remove the Celsius, what's this all about? Calorie per gram. What's this all about? Calorie per gram. So there's a gram also, right? You get the point? So this is the general heat capacity. Okay, you get the point? And then, if that is calorie per mole, that is your molar heat capacity. Okay, calorie per mole. And then calorie per gram. Okay? Because if you say specific heat capacity, it will not jive for the previous because we say specific heat capacity has already have the temperature and the gram. Since you remove the temperature, you will just only say the heat capacity. You get the point? Now, if you put the mole on the denominator and the other one, this will be your molar heat capacity. You don't have to put specific again because specific is always grams, grams, kilograms, kilograms. The mass will be in the denominator. I will teach you a billion of times. I will never be tired. Okay, got the point for this specific. Okay, even though how redundant am I will suffer that as long as I can spread the right information. You get the point, things like that. Okay, guys, so we have 1 calorie per gram degree Celsius. Okay, now, so convert this into joules per gram degree Celsius. Why you convert that into joules? Okay, this is the reason. Because calorie is more on the biochemical processes or biochemistry inside our body. The calorie. That's why, how many calories you burn yesterday? So the applicability of the unit is mostly applied in that situation, like the food products, the food intake, the food metabolism. That now, joules will be applicable more on the physics, like that, with pushing this one chair, like that. Joules will be more applicable. But it doesn't mean also wrong. Okay, because I'm talking only the more applicability. You get the point? Or usually mentioned or usually applied. Things like that. Because they are all correct in the first place. Right? You get the point? Things like that. Okay. This is joules per gram degree Celsius. O, diba? Okay, you get the point. So can I also say watts per gram degree Celsius for this, sir? Actually, if you try to be strict, it's okay. But sometimes, if does not appear to the studies from our previous scientists, even though you fabricate derivation in which that's also logical, you will never use that. It's okay because watts is the unit of electrical energy. Joules per second. 1 joules per second is equal to 1 watt. And 746 watts is equal to 1 horsepower. And this is the energy of the motor can drive, or electric motor pump, things like that. Okay, so that's the unit of energy also. Why now? Okay, but the problem is, the applicability is not widely used. Okay, it looks like strange. Maybe in a hypothetical examination, that's not subject for reality, measuring only your comprehension. Because there's also tests and exams like that. Even though not subject for reality, the main purpose only if you understand or not the concepts. That's why even though the units are not really practical in the present times, like that, still even though strange to hear it, things like that, because the purpose only is to test your understanding and comprehension. It's also possible, but I'm not telling you how that's subject to reality. Okay, but you can have that as a sort of just like playing a game in order to widen your knowledge about the specific context of your lessons, things like that, or whatever, or your topics. Okay, because there's a lot like that, especially in math. There's a lot of hypothetical questions. Okay, usually denoting variables like that, whatever, or different types of nomenclatures, just to designate that how far your knowledge will be directed into comprehensive understanding. Okay, not limited, like that. Okay, got the point. Okay, now how can we convert this into joules again? So you need to memorize this. 1 calorie is equals to 4.184 joules. Okay, so basically you will say 1 calorie per gram degree Celsius is equal to 4.184 joules gram degree Celsius. Okay. Now, what's strange here, because especially physics, physics loves kilojoules most of the times. Kilojoules, kilogram, then convert. Okay, 1,000 joules is equal to 1 kilojoules. So it's easy. 1,000 grams is equal to 1 kilogram. Okay, so don't make yourself complicated. Use the conversion factors. Okay, get the point. And then, you know the point. Sometimes also they will drop the grams, let me change with moles, then do the dimensional analysis conversion. Okay, get the point. Things like that. Okay, this is the specific heat capacity of water. Okay, like that. Specific heat capacity of water. Okay. Heat capacity or specific heat capacity of water is very high, okay, compared to the hydrocarbons because water is a polar molecule. There's a lot of unpaired electrons or lone pairs that need to be reacted, very unstable, and then intermolecular forces are very strong. But these hydrocarbons, the intermolecular forces are very weak because most of the electrons are being shared between carbon and hydrogen. That's why most of them will have a lesser boiling point and melting point and flammable in nature. The more it will become polar, the more it is less likely for flammability. You get the point? And the more it will boil very long. Okay, things like that. So if the question in the future will say, which of the following has a higher melting point? Sometimes like that also, right? A sugar solution, B salt solution. If you don't have an idea about the theories, oh, how can you do that? And it's not a problem solving. So it requires very deep critical thinking or analysis for that. And if you love concepts, theories, and principles, you can understand that. Okay, that's why when I was in college, I will never focus in problem solving that much. Okay? For me, if there's an above average or average, I will stop as long as I understand really how it is being done, like that. Okay? I will not go to the too much difficult that, for example, calculate the number of tiles when ammonia will go to the toilet. Nakakaloka with an acceleration of, ay, nakakaloka, how to compute that one. Okay? So others loving that they're kept on talking like that. I'm just listening in the bench and I'm not, when I was in college, I'll never talk too much. Okay, about the lessons, it's just by myself. Okay, things like, but during reporting, English language, speech, like that, so I'm very, very vocal and, mutingog jud ko. Okay, things like that. Maguna-una jud ko sa mga volunteer. Okay, in reporting. Things like that. Di ba, mga classmates? Especially sa mga defense thesis, feasibility studies, or whatever. Okay, get the point. Things like that. So, I'm not really, telling that I'm superior in intellectual capacity, but I'm just building very strong self-confidence. Things like that. Self-esteem is very high. Okay? Things because I normally have that because I'm joining also singing competition or singing contests or different competitions in my entire life, whether it is athletic or academic or extracurricular activities. I joined track and field in my elementary, 200-meter dash, like that, 400-meter dash. That's why today I love to walk. You can observe me, I love to jog because I have also that kind of personality when I was very young. Okay, things like that. And then curricular activities also, like for example, intramurals, cheerleaders, organizing entertainment number for the group in the class. So I usually act as a leader to conceptualize, our presentation number in the Christmas party or whatever. Things like that. So I'm very also active to that. Okay. And also academics, like joining competition in sports writing competition, essay writing competition, editorial writing competition, science quizzes, like that. So I said to myself, oh God, thank you so much for these gifts. Things like that. Okay, that's the point. Okay, it's marvelous and wonderful, right? Okay, now we have here 4.184 joules per gram degree Celsius. Okay, you got the point? Ano siya na? So, muna naman specific capacity. Now, if you remove the Celsius here, okay, what will happen? Here, if you remove your Celsius here, okay, since you are referring to this, that is your latent heat of vaporization. Okay, I love this word, vaporization. Okay, get the point? What's the difference between evaporation and vaporization? Okay, what's the difference? Okay, so vaporize is the action verb Okay, and then the other one is evaporate. Okay, the vaporization starts after boiling point has been reached. Okay, but the evaporation starts from the moment you apply the temperature until the boiling point has been reached. That's why the gas molecules will dissipate and scatter or diffuse into the atmosphere. That's the difference of to use vaporization and evaporation. You get the point? Okay? Things like this. So throughout the whole course of your heating, you may say evaporation has taken place from initial to final. But you can never say vaporization in the initial. The vaporization will always occur after the boiling point has been reached. Okay? Because the exact or adequate vapor will just move out when 100 degrees Celsius will is attained or achieved. Okay, that's why vaporization also will not be used always in the phase change. That's why we always use evaporation rather than vaporization. If you say the change of liquid to gas state. So in science, it's always mentioned evaporation. It's not vaporization. That's the reason because it's starting from the initial point until to the last point. But if you say vaporization after only the boiling point has been reached, and then the vapor will be diffusing into the atmosphere. Okay, so it's very clear, right? Okay, but you can say that latent to the vaporization here because you are considering now 100 degrees Celsius here in your computation of the latent heat. Okay, so if I will change this specific capacity 1 calorie gram degree Celsius into latent heat of vaporization, then I must use 100 degrees Celsius. So it matched with our definition that you can use only vaporization after the boiling point has been reached. Okay, and that's very clear. You get the point? Okay, so you can now distinguish, differentiate between vaporization and evaporation. 5 points, 10 points, like that is a examination to measure your comprehension, total comprehension. You get the point, things like that. Okay, now if I will convert calorie per gram of Celsius to latent heat evaporization, what comes on my mind? I need to incorporate the boiling point, which is 100 degrees Celsius. So obviously and evidently, my temperature unit will be lost somewhere in my calculation. So I will say 1 calorie per gram degree Celsius times 100 degrees Celsius vaporization, cancel Celsius, what will be left? 1 calorie per gram times 100. So we have now 100 calorie per gram. What is your 100 calorie per gram? This is now your heat capacity. Okay, heat capacity in terms of 1 gram of a substance. Get the point? Things like that. So there's so many like this. But this is strange in examination. Usually they will never try to ask this. They still have to find the molarity for this. Then use the molecular weight. Okay, things like that. Times, okay, like that. So, water, 18.06 atomic mass, grams. Okay, 18.06 grams per mole. So cancel gram, what will be left is calorie per mole. So this is now your molar heat capacity. Because sometimes it will not be mentioned there molar heat capacity. It will just state directly heat capacity, but the unit is in terms of molar. Not all the time it will be specified also. This is the part of the quality of the discussion to eliminate the ambiguity. Okay, in the declaration of the terminology in the problem solving. Okay, though it's only minor, but it will help us a lot to have an idea. You get the point? Because to be precise also. Okay, so 100 times 18.016, pila man na siya B. Okay, calculator please, Charles. Okay. Nakakaloka, ano ah? Okay. Now, we'll give you a problem solving that starts from a very basic with 4 physical processes. Then you have to apply all the phase changes. Okay? So that we can understand really. So that if you will face examination regarding this, then more or less we will become perfect. Okay, get the point? Things like that. Okay, in this topic only, because there's a lot of topics in science, right? Okay, get the point. So 100 times 18.016. Oh my gosh. So we have 1,801.6 calorie per mole. Okay, 1,000. Okay, 1,801.6 calorie per mole. We convert this to joules per mole. So 1 calorie is equals to 4.184 joules. Okay, then multiply this by 4.84. After that, you convert that to kilojoules also. Let's try. Okay, so dahil siya na, so times 4.184 joules na siya, no? Okay, ganun siya. So, divided by 1,000. So, this is 7.5 kilojoules per mole. Okay, 7.5 kilojoules per mole. Okay, and also, okay, so 1 kilojoules is 1,000 siya, no? Okay, times 1,000 is equals to 7, okay, mahimo siyang 7,537, okay? So, it depends na ni mo sa yung pag-compute ang conversion. Conversion is very clear here. Okay, now, we will go to the latent heat. Okay, the latent heat of vaporization. Okay. I'm just converting that specific heat capacity into the latent heat of vaporization, but we go back to the standards of latent heat of vaporization. Okay. Latent heat of vaporization. Okay, I will teach you something. If the examination will say heat of vaporization, is just the same saying latent heat of vaporization. Okay, that's understood. Okay, so you will say delta H V, meaning heat of vaporization or latent heat of vaporization. Okay, ganon. Okay, so you have 47.01 kilojoules per mole water. Okay, at standard temperature and pressure. Okay, now your latent heat of fusion. What is fusion process? Latent HF. Because guys, in the topic of heat energy, they will not use the melting. Okay? From solid to liquid, like that. Okay? The solid to liquid. Liquid to solid is freezing. Okay? But solid to liquid is melting. Things like that. Then there's also gray area there. Why both of them have 0 degrees Celsius standard? The standard melting point of water is 0, and also the freezing point of water is 0. Why? I will explain later. Okay, get the point, things like that. That's too confusing, right? Okay, so latent heat of fusion will be 6.01 kilojoules per mole. Ganun. Okay. And then if you say latent heat of sublimation. Okay, of sublimation. What's sublimation? A change from solid to gas or gas to solid. Okay, the latent heat of sublimation. Okay, that is gas to solid, right? Okay, so review this one. But sublimation, it means to sublime, meaning solid to gas. Kaya sublime man siya, meaning it will vaporize. So, solid to gas. Okay, get the point? Gas to solid ang deposition or desublimation. Okay, parang na nato guys, sublimation will be solid to gas. Okay, like that. Okay, get the point? Okay, liquid to gas will be evaporation. So the reverse gas to liquid will be condensation. Okay, like that. Solid to gas, example, the naphthalene ball. Okay, like that. Get the point? Then gas to solid, okay, meaning to say this is desublimation or deposition. This is not quite discussed so many times in our education, but I just maximize the gas to solid. Okay, get the point? Things like that. Latent heat of sublimation, delta H S, right, is equals to 75.01 kilojoules per mole. Actually, I already solved this before having this in the whiteboard because it will take a longer time for me to, to derive, and I have a very small whiteboard. You get the point? So these are the constants to be used for water. This is only for water. There's a lot of liquids like ethanol, a lot, carbon tetrachloride or whatever. Okay, so it depends. Okay, but most of the times there will be a table for that. Table. And then you will look at certain temperature and pressure. Then sometimes the problem solving have, but sometimes don't have. Okay? You get the point? Ano siya no? Natong constant. Okay. Now, you will use this somewhere along the way in your problem solving. You get the point? Now, let's go back to the basic concepts of three phases of matter. Okay, three phases of matter, solid, liquid, and gas. For example, if I have here solid, okay, like that. Okay, nakakaloka no? Chart. Okay. Solid, liquid, and gas, mga palagi-naging. Okay. So for example, I have here solid. Solid. Class, this is solid. Here, liquid. Okay. Like that. And here, there is a gas. Okay. These are the three phases of matter, three forms of matter, three states of matter, three stages of matter, and three types of matter. Okay, things like that. Now, when the liquid changed to gas, so let's put an arrow going here. This is evaporation. Okay, evaporation. When we take the reverse, this is, okay, this is condensation. You get the point? Okay. When the gas condensed, so it turned into liquid. So that's why we have condensed milk. Like that. The word condensed from the process of this. Okay, you get the point? So condensed meaning liquid or liquefied through the process of condensation. Okay. Now, you will apply now the delta HF of condensation. Sir Sotero, you don't discuss that a while ago. It's simply the reverse of the evaporation. This is negative. Okay, negative 47.01 kilojoules per mole. Okay, you get the point. Okay, now, if it's solid to gas, what's this all about? Solid to gas is really sublimation. Okay, sublimation. Okay, like that, right? Solid to gas. Then we have also the delta HS, right? For sublimation. So the delta HS of sublimation meaning heat of sublimation or the latent heat of sublimation. So we have 75.01 kilojoules per mole. Okay. Now guys, if the problem solving will give you the kilojoules, joules, calories, just multiply that with the molecular weight. Okay. Divide that with the molecular weight. So that it will cancel the mole, blah, 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 so and so, whatever. You get the point, especially if the mass is given. It depends on the units what they're using there. Okay, you get the point? Things like this. Gas to solid. Gas to solid. Masama ni siya. Okay. Actually, you need to remove the sublimation. That's why desublimation or deposition. This is not common, deposition. Okay, like that. So, this is also very tricky because it has to do something when you don't deposit something. And it's very far. So, I will deposit money in, in jazz. So the process of depositing money, it looks like deposition, right? Because deposit. So once you deposit, the process will be deposition. But it's not like that. The deposition is a change from solid to gas to solid. Imagine it's very far from the definition. Okay? Did you meet that kind of word, deposition, and you use that in another context? The deposition of $1,000 in the bank is a good investment. There's nothing, right? In the books or references book, whatever. So it will never be used in that way because we have a special application for that in science. That is in a phase change in chemistry, a change from gas to solid is called deposition, even though the action verb is deposit. Okay. Diba? So once from gas, it will become a solid, so it is deposited as a solid substance. That's what it means. But never use that in another context, by depositing the money, like that, or whatever. Okay? Because it's not really correct to say. Okay? You will say, the deposition of, scales in the pipelines are due to excess hardness and salts of the water content that pass through the pipeline. Things like that. Okay, so you'll never say deposition also. You will say accumulation. Another, process. Okay, like that. Okay, or the penetration or whatever. Okay, there's a lot, right? Okay. Or you will modify the sentence. The deposited scales, but you will never use the deposition. The deposited scales of salts in the inner line or outer layer of the pipeline was due to excess total hardness after the results of the water analysis parameters, like that. Okay, so you will use deposited instead using deposition. Okay, what man yun ang deposition in the dictionary? You get the point? Things like that. Okay, so just tell me if you hear somebody that telling deposition in the normal speech. Not in science. I doubt not. Even single one. Okay? Because this is not the right term for that. Okay? The right term is for science phase change. A change from gas state to solid state. Okay? That's deposition. Now, from solid to liquid, what's this? Okay. Solid to liquid. Okay. O sama na siya matkuan. Kuan na niya. Okay, what's that all about? Solid to liquid. What's that? Liquid to solid. Okay. So what's that all about? Solid to liquid. For example, if I have, let's say, pwede ba na akong candle? Okay, if I have a candle, then it will be melted. Charot. No, if it melts and then back then it will become dry also, like a solid again. Okay, it's not candle. So if I will melt, let's say mercury, the solid will become liquid. What's that? Okay, so that is actually fusion. Actually, fusion and melting will just be the same, but the right and perfect is fusion. But the same meaning, but the technical term to be applied really for professional way is fusion instead of melting, because we have latent heat of fusion. So latent heat of fusion, delta HF is equal to 6.01 kilojoules per mole. Okay, now the reverse will be, from liquid to solid. Okay, what's that? This freezing, right? Liquid to solid, freezing or solidification. Okay, then liquid to solid. Okay, this is gonna be fusion and melting. Okay, you get the point? So check your triangle if there's a reverse, because usually when you discuss there will be a reverse, especially in this area of fusion and melting. Because normally when I was in college, I always be confused in that part of all of all changes. So let's do it again. Okay. Okay, guys. Okay. Ang hirap kumita ng pera. Okay, or the orada. Okay, we got the point. So it's gonna be like so. Liquid to solid. It will become solid. That is solidification. Solidification. So when it becomes a solid, so it will freeze. So freezing point, like the ice in your refrigerator at 0 degrees Celsius. Liquid water to solid water. Okay, solid water is an ice, right? Things like that now. Freezing and solidification. Now, solid to liquid. This is now the melting. Because you melt the solid to become liquid. Example, mercury. Okay, things like that. Mercury with atomic weight of 200.59 grams per atom. Okay, so melting point. Melting or let us say fusion. Okay, so solidification and freezing, melting and fusion, deposition and desublimation, okay, like that, and sublimation, evaporation and condensation. These are the phase changes. Okay, get the point? Ganon. Okay, so any questions so far? Okay, understand this and memorize this all the time because most of the chemistry quizzes have this always in the easy round, average round, difficult round, like that. Okay, talking about phase changes only. Okay, and then at what temperature, like that, okay? At what temperature that the water will become superheated? At a superheated steam, like that, okay? You get the point? Ganon. Okay, steam. We are talking about the steam. Okay, steam. Steam is a gas, a vapor. Okay, things like that. So that's the meaning. But to be specific, that is steam in a higher level way of saying. That's that. Because vapor is always for all. Yes, for all, right? Steam also for all. Oh no, it's only for water. When you speak steam. Correct me if I'm wrong, huh? When you say steam, it's only for water, not for alcohol, refrigerant, like that. But all substances, liquids, all will be considered vapor in its gas state. Steam is so special for water only. Is that the point? And gas also for all. Gas and vapor for all. Steam is a gas state and vapor state of water. Exclusively. Okay, the appropriate term for that. But you can still also vapor, water, vapor. Right? You can also water gas, but water gas is not really commonly used, but actually it has sense. Okay, but what is practiced most of the times is not like that. But I'm not saying it's wrong. It's never used all the time because we never heard it. But if we try to be strict, it's still okay. Water gas or water vapor is just the same. You get the point? Things like that. And the steam. If you say steam, don't put water or steam na talaga siya. Okay, the water steam is not okay to listen. Okay, because what is steam? That is the vapor state of the water after evaporation process. Okay, the point, things like that. Okay. Klaro na? Wala pa. Okay. Nakakaluka, no? Okay. So after this, we will have a problem solving. Okay, about heat energy. Okay, that's the point. Now, charat. Okay. So we need to use the phase diagram. Okay, to understand and interpret well. Phase diagram. Okay. For example, this one, going there, going there, going there. Okay, this is your solid, liquid, and gas. Okay, so we have temperature here, and we have the heat energy here. H, temperature T, hit here. Now, so there's a common point between the liquid and the gas and the solid. So what this point all about? Okay. So this point is known as the tripole point. Okay. Tripole point, okay, is the temperature and pressure at which the three substances phases of water, okay, because we mean water is a substance in three phases, liquid, gas, and solid, are in equilibrium with each other, meaning they are equal in the behavior, how they move, their properties, at this certain temperature and pressure that they will meet here. That is a tripole point. Okay, so or we can say that in a diagram-based explanation that all the three curves of the latent heat of vaporization, sublimation, like infusion, will be equal or meeting with each other. So that's another way of explaining. So is a question, 20 points. Discuss what is tripole point in your own words. Like that, the teacher will ask you in the second, in the booklet, in the prelim, midterm, finals. Oh. Discuss what is a tripole point in a phase change. Ganon. 50 points, 30 points, 20 points. This is a good type of examination because it's asking you really the total comprehension. Okay, because it's not always all the time numbers, right? Because the point you need to reason out. You get the point. So, muna siya ito sa tripole point. Okay. Diba? Okay. Now, if this point will be meet, okay, so this three will be equal. Liquid equal to solid like that, and gas. Things like that. You get the point? Ganon. Then at this point also, you may confuse which among them is liquid, which among them is solid. That's because they have the same behavior, they have the same characteristic because they are meeting in the same point. So their properties are really equal thermodynamically at equilibrium. Okay, the three phases, solid, liquid, and gas. Muna siya, tripole point. Your identification is very easy. Tri, meaning three. Okay, things like that. But only the how you explain matters a lot, right? Okay, so that's it for our, what's that guys know? Our tripole point. Diba? Okay. Now we go to the dew point. What do you mean by dew point? DEW. Let's say we have Mountain Dew. The DEW has meaning in science. So that's the process of producing Mountain Dew. Nakakaloka. Okay, the points. Okay. Okay, dew point. What's that all about? Okay. So manaka sa tripole point. Okay. Like that. Okay. Then let's go to the dew point. DEW. The pronunciation is dew point, not dew. Okay, dew point. Okay. What is a dew point? Okay. This is the temperature, okay, at which the air must be cooled to become saturated with the water vapor. Okay? So meaning it will be vaporized. That's why dew. Okay, get the point. Now, what condition? Constant, okay, constant pressure of the air and the water content. So if it is not constant, then it will not achieve a dew point. Things like that. And now, below your dew point, at this temperature below, now it will go back to liquid form. Okay, things like that. You get the point? Okay, so if it goes beyond dew point, so it will vaporize, vapor, but below the dew point will be liquid form. Okay, things like that. You get the point? So the word here is very cold, is very important, cold. Okay, the K word. So cold, COOLAD, meaning to say the temperature at which the air must be cooled to become saturated with the water vapor. Okay, saturated meaning they will be equal. Things like that in properties, characteristics like that, blah blah blah, so and so. Okay, another dew point. Okay. What about critical point? Okay. What about critical point? If we mean the equality of the thermodynamically equilibrium of solid, liquid, and gas, here in our critical point, two phases only will be in equilibrium with each other. Okay, that is only the liquid and the gas. So this is the highest temperature and pressure of a pure substance between the liquid and a gas at equilibrium. You get the point? We need to say, this is the point also that it can act as a liquid, it can act as a gas, like that. So there's no distinction anymore which among them is liquid and a gas if this point will be reached at a certain temperature. Because this point has specific certain temperature to achieve before attaining this kind of point like that. Okay, so that is critical point. So at critical temperature, at critical pressure, meaning critical point is very obvious, right? Things like that. So why critical? Because highest temperature and pressure, it's not common to achieve. So it's very superlative, highest. So how can you do that? Highest temperature, you need to say. Okay, so at highest temperature and pressure talaga siya, no? So the characteristics and behavior of liquid and a gas will not be distinguishable. Wow. There's a term distinguishable. Sorry, we cannot distinguish already. There's no distinction. Okay, so critical point. Okay. Now, we have also here flash point. What is a flash point? Okay, flash point is the basis of your flammability. Take note, guys, no? So, flammability, wait ha, flammability and inflammability is the same in meaning. Take note in English, exemptions. Inflammability, inflammable, and flammable are just the same in meaning. But most of the English language terminology, if you put in, is the opposite or without. For example, complete, incomplete, means to say not complete, right? Subordinate, insubordinate, meaning you are not a subordinate. But inflammable and flammable are the same in English. The same also with famous, famous and infamous. So popular, still popular also the word infamous, not popular, ha? Okay, because these are all confusing words, exemptions in English in the prefixes utilization. In and like that, okay? You get the point in English, okay? Unauthorized, incomplete, like that, okay? Non-uniform, things like that. So these are prefixes in English, the opposite of something. Okay, so hydration, dehydration. So D also have re also, pre, post. So these are all prefixes. Okay, for example, prepay, postpay, like that. So these are prefixes put in the first sentence, first letter, prior to the first letter. So generation, regeneration. Okay, repeat, iterate, reiterated. Okay, you get the point. Incarnation, reincarnation, like that. Okay, there's a lot in English. Okay, and D also. Okay, let's say valuation, devaluation, things like that, and the removal of value for something. Okay, the same also. Example, organic chemistry process, hydrogenation, so dehydrogenation, the removal of hydrogen. Okay, that's D. Okay, another promote, demote. Okay, but in here, it's not de-promote. You are eliminating the pro, but you change that with D, meaning losing the possession. So mobilization, moving. So demobilization, meaning it was not mobilized, it's not transferred, it's not shifting, it's not dynamic. Okay, it's not transported. That's why demobilization. The root word is mobilization. That's also prefix in English. Okay, and also in like that. These are only some of the examples of prefixes in English because we have also suffixes in English. Okay, you get the point. So, except for inflammable and flammable are just the same. Famous and infamous. Okay, things like that. And also, query and inquiry are just the same in meaning. Oh, I have some queries regarding what happened. I have some inquiries. It's just the same in meaning. Okay. But this is very strange in query. So query, okay. You also say inquiry. You have also inquiry and other spelling are just the same in meaning. So inquiry, I, first letter, and inquiry, E, are just the same in meaning. Meaning asking information. And also query, the same meaning. So take note. Okay, how to maximize that vocabulary for our grammar in English language. You get the point? Things like that. Okay. Now, what is a flash point? So, what do you mean by flash? Like that, like like a flashlight. Okay. So what's that? The lowest and minimum temperature at which the substance will flash or will produce or will ignite a fire in the presence of ignition source. So the key words here, ignition source. Okay, because once you have the ignition source, you have the heat. Okay, so no need to mention the heat. Okay, because heat will be complementary or is intrinsic with the process of ignition. That's why our definition will be like that only, right? Okay. You get the point. Now, we have also the auto-ignition point. Auto meaning automatic. We'll just cut off that one because that's too long. Auto-ignition. Okay. Like that point. What's this all about? Okay. The same story with the flash point. Lowest and minimum temperature. Okay. But at normal and standard atmosphere without ignition source. So meaning to say this is dangerous. Imagine it will ignite even though there's no ignition. So there's also substance like that. Okay? You get the point. It's number 5. Number 6. Okay. Ignition point. So the gray part here, the GEREY, meaning confusing, ambiguity, skeptical, ambiguous, equivocal, like that, abstruse, meaning perplexed, you get the point, obscure, or what else, baffled, steered, like that, fast, meaning to say it's very complex that you cannot understand with too much interpretations, like that, you get the point. So, or enigmatic, you get the point. So, vocal. Okay, so ignition point, like that. Okay, meaning confusing. Okay, ignition. The confusing here are items 4, 5, and 6. Flash point, auto ignition point, and ignition point. And then, what is ignition point, by the way? Okay, ignition point. Okay, again, minimum and lowest temperature. Okay, at standard and normal atmosphere will ignite, but in the presence of ignition source. What's the difference between 4 and 6? Because flash point, it's not on standard and normal atmosphere, but the same thing, they have ignition source. Okay, auto ignition without ignition source. Okay, but the same here in 6, normal and standard atmosphere. Normal standard atmosphere meaning at standard temperature and pressure. Okay, that's what it means. Okay, get the point. So maglibog din ka sa auto ignition, flash, and ignition. Now we have the last fire point. Okay, what do you mean by fire point? When you see a fire occurring, the fire point has been reached. Meaning to say, this is the burning process. Burning process continuously, meaning the heat is self-sustaining even though you remove the ignition sources. Okay? Wala na siya, nothing. There's no ignition source anymore. Okay, there's no heat anymore. But the heat is self-sustaining to that particular fire or core. That is burning process of a fire continuously with its self-sustaining heat without or removal of the ignition source. Wala na siya ignition source because the fire point has already achieved. Okay, so things like that. At least you will know this: tripole point, dew point, critical point, flash point, ignition point, fire point. Now, in these items 1 to 7, the basis of your flammability is the flash point. Okay, this one. Okay. Ganon. Now, if I would say lower explosive limits, what's that all about? Upper explosive limits, what's that all about? Okay. So, your keyword will be explosive from the center. Okay. So, what's that all about? It means explosion rate, the explosive rate of your substance. The chance of exploding with a flammable and substance and heat ignition source inside the system or in the environment or whatever. So lower explosive limits. That's why usually driven by flammable liquids, flammable gases like that. Okay? Then it has a chance to explode and have an explosivity rate, then that is your lower explosive limits, because this is the minimum concentration or the lowest concentration in which your substance will explode, okay, and cause explosion. Now, what's the difference between the flash point? Flash point refers to the temperature. Lower explosive limits refer to the concentration. You get the point? Then, if we try to take the opposite of the LEL, which is the upper explosive limits, that's also the maximum concentration that the substance will explode or cause explosion due to the flammable liquids with ignition source. So that is LEL and UEL. So LEL will be present in your environmental monitoring device because most of the times the hazards will be fire and explosion. Most of the times, especially when we deal with hazardous chemicals and substances, because most of them are flammable and there's a chance of explosion rate. The explosion will not be noticeable or conspicuous by our eyes or evident, but it really exploding. We just don't know. The point, because the explosion would not mean only that you will hear a sound. There's also an explosion that you will never hear a sound. That's already explosion. Meaning minimal and minor explosion. Okay. There will never be a fire coming if there's no explosion, because explosion doesn't mean every time that there's a sound. Okay. It will like that only. Then for example, the debris will go there, like that, it will move like that at the first point of the fire coming. So that's already explosion. Again, explosion doesn't mean all the time with sound and with noise. Okay, once the materials are moving, okay, at a certain velocity, when the fire point started, okay, then there's a fire, there's explosion, but it's a minimal and minor explosion, okay, because of lower explosive limits, okay. It's not limited to the flammable, but also the wooded materials, has also LEL, but you know, it looks like the LEL is not really that very important to consider. Some are negligible in effect. You get the point? You need to say you will never consider that much because, but the clue here, there is, okay, but negligible in effect. You get the point? Just like 0.001 something, like just traces, okay? For example, if we're measuring the parts per million of, parts per million of sulfur in the presence of potato you eat. So there's a traces there of, sulfur, 0.002 ppm, and that's too small to consider, right? Okay, but we are not telling that there's no sulfur when you eat French fries. Because originally, the potatoes have traces of sulfur in nature. let's say 0.002% sulfur, 0.00. It looks like negligible in nature because it started with 00 something. But there is that very small amount. Okay, just like for example, if you try to consider that the air composed of 0.02, CO2, 0.934% argon, like that. Okay. Okay, then that is not also very important. That's why we try to eject them from our equation. We'll just use the nitrogen and oxygen in our ideal gas law computation. This is 21% the volume of oxygen and 79% of nitrogen because of the fact it's too negligible to consider a point something something chuba chucho. You get the point? But there are traces also of other gases in the atmosphere, especially nowadays because there's industrial pollution in our air pollution due to contaminant gases and hazardous air pollutants. Okay, you get the point. That's why environmental engineers are very in demand in USA and Europe countries and some parts of Asia countries. Okay, you get the point. The other Gulf countries already hired specifically environmental engineers, but not all the time because some of the safety engineers will act also sometimes as an environmental engineer because the company is saving money for that particular position. Okay, get the point. Especially if the company is just local, they are producing products locally, it will not be transported or imported to another country. That's why the regulation is not very strict. You get the point. So if it's not very strict, that's why they can really positioning and they can save money for that because nobody will audit. You get the point? Things like that. But for the world-class companies, multinational companies, they will be audited and regulated all the time by different, regulatory statutory requirements, or legal and local or international requirements. So that's the time very strict also. You get the point. They have also one environmental engineer, one industrial hygienist, another safety officer, safety engineer, safety supervisor, safety manager, safety consultant, like that. The complete structure of the organizational setup of safety department is very complete. Okay. So, but for the not world class, the safety engineer will do as an environment. The fire engineer will do as a safety. You can do a lot. Okay, things like that. You get the point? Ganun siya. But in construction industries, very wide the department. There's a lot of safety officers, engineers, and like that. Okay, and consultants. Okay, but in manufacturing, only few. Okay, you get the point. Things like that. You get the point. So, they will choose really the competent professional to be the OSH. Things like that. You get the point? Okay, any questions so far mga palangakong hitad? Nothing, right? So, I will give you problem solving after this discussion of heat, explanation, or heat topics. Okay, diba? So, heat, kaya thermodynamics na nila siya, no? Okay, get the point? Okay, bye-bye guys everybody. See you later for our problem solving. Hello, if you like this video, you can comment below in the comment section. And please subscribe my YT channel. I will be grateful to that. Remember that Jesus loves us. Bye-bye. God bless everybody. See you later. Charos. Charwing.